Hi! Today we're going to have a look at what all computer instructions are broken down into: binary. We're going to have a go at turning characters into binary and finally cracking some code. All the coding you've learnt so far is understood by us and it's understood by programmers. As we type it into the computer then has to compile it and turn it into something else that the computer will understand. Now, some of you might know that computers only understand a series of ones and zeros. Everything that runs inside a computer is made up of ones and zeros. We understand decimal numbers. We say decimal numbers have a base of 10. So they are base 10 numbers. That's because there are 10 possible values. 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 possible values. Computers, however, only understand 2 digits, ones and zeros, which is binary. So we call that, if we call decimal base 10, because it understands 10 possible values, what do you think we call binary? Base what? We say that it is base 2, because there are only 2 possible values, 0 and 1. Now that we've understood that computers only understand ones and zeros, we need to find out how to convert decimal numbers, the numbers that we understand, into binary numbers so the computer can understand them. To do that, I want you all to draw out a framework, which is what I'm going to do now. So if you get your notes and follow what I'm doing. First of all, we're going to start from the right-hand side of the page. Give yourself plenty of room. And then the right-hand corner of the page, we're going to do the number 1. And then to the left of that, we're going to double 1. So we're going to do 2. And then we're going to double that. 4. And again. And again. 2 times 16 is 32. 2 times 32 is 64. And finally, we're going to finish on 2 times 64, which is 128. So you should have 8 numbers, 8 decimal numbers up there. So 128, 64, 32, 16, 8, 4, 2, 1. And that's the framework we're going to use. Now we have our framework, we need to figure out how to actually use this to represent decimal numbers in binary. So first of all, we're going to start with a nice easy number. We're going to represent the decimal number 4 in binary. Now these numbers at the top here can be used as a sort of mathematical grid. To represent the number 4, we need to put a 1 underneath all of the numbers that will add together to make the number 4. So because it's a nice easy number, we can look across the top of the frame and figure out that the only one that we need to make the number 4 is this one. So we can put a number 1 underneath the decimal 4. The rest of them we will write zeros underneath, because we don't need any of these numbers. So if we add up all of these numbers, we've got no 28s, we've got no 64s, we've got no 32s, we've got no 16s, we've got no 8s, we have 1 4, we have no 2s and no 1s. So 4 plus 0 is 4. Now we've done something easy, let's make it a little bit more difficult. Let's try and make the number 79. So we know that we won't need 128 to make 79, that's too big. So we'll put a 0 underneath there. 64, that will go a long way to helping us make the number 79. So let's do a 1 underneath 64. Now what do we need to add on to 64 to make 79? 15, excellent. So we need to come up with a way to make 15 now. So we know that we don't need a 32, that's too big. 16 is also too big. 8, that could work. If we need 15, we could go with 8. So we'll have 8. we draw a 1 underneath number 8. Now, 15 minus 8 is what? 7. So we need to make up 7 somehow. Oh, that's convenient. We have 4, 5, 6, 7. So we've put zeros there underneath the numbers that we don't need to use. So 128, 32 and 16. We don't need to use these numbers. But if we add up all of the numbers that we have a 1 underneath, we should get 64 plus 8, which equals 72, plus 4, which equals 76, plus 2, 78, plus 1 equals 79. So now we know how to convert decimal numbers into binary numbers, but we need to figure out how to convert decimal numbers into binary for letters and for numbers and symbols. For that, we're going to have to use an ASCII table. You can find an ASCII table if you just go to Google Images and type in ASCII, ASCII, table, and let's do PDF. Okay, and any of these will do. Go for something that's quite simple, straightforward looking. So let's have a look at this first one here. I'll zoom in a little bit. Yeah, so here on the left hand side we've got the decimal, and then we've got the actual character there. So we've got some numbers, symbols and letters. So that's easy enough to follow. As long as any of these will do, as long as you can pick out the decimal number and the symbol. So even though this is in what looks to be Spanish, you can see the decimal number here and then the letter or number or symbol here. Any of those will do. Once you have your ASCII table, you need to figure out how to actually use it. So for this particular table, we're going to ignore all of this for today. We're going to look at from here, from this row here that has the character number 0, see character here, 0, and we're going to look at the characters A to Z here and A to Z here. Don't worry for the moment about the different symbols that you see dotted around. You can always use those later on. Within this table, the only columns we're going to look at are, for the moment, the decimal column, this one here, and the character column. They're the only ones we need for the moment. Later on in the course we'll learn how to use hexadecimal, which is this one here. But for now, just think about this column and this one here. Now, how do we actually use this table to figure out what the binary is for a certain character? What we need to do is find the character we're looking for. So first of all, let's see if we can type in the letter C. So C for Cornwall, best name ever. We need to find out what the decimal number assigned to the character C is. So the decimal number assigned to the character C is 67. So we now need to make 67 in decimal turn into binary. Let's see how we can do that. So we know the letter C is equal to the decimal number 67. We need to find out what 67 is in binary. So let's draw out our frame again. 1, 2, 4, 8, 16, 32, 64, 128. We need to figure out how to make 67 out of that. So we know that 128 is too big. Put a 0 underneath it. 64, however, very close to 67. So 67 minus 64 equals 3. So we need to find which numbers add up to 3 out of the remaining ones. I'm going to go with 2 and 1. There's nothing else there that we could add up to make the number 3. So the rest of the numbers have a 0 underneath it. So we now use 64, 2 and 1, which equals 67. That means if we were to write the letter capital C, uppercase C, in binary, we would write 0, 1, 0, 0, 0, 0, 1, 1. I hope you've enjoyed learning how to use binary today. Now if you'll excuse me, I have to go off and save the world from an attack of giant spiders. Bye bye!